Hi, hello. I'm Kiran Kumar from Nature of Physics. Today topic is work energy theorem. Work done by a net force on a body is equal to change in kinetic energy. This is called work energy theorem, student. Please do like and subscribe our channel Nature of Physics. Please watch full video, you will get clarity, student. So work done is equal final kinetic energy minus initial kinetic energy, that is change in kinetic energy. W is equal delta Ke. Okay, so considering a person kicking the ball with a force F, its initial velocity is u and final velocity v, student, and its initial displacement from A position to B position is s, and change in velocity give the acceleration. Due to the initial velocity the body get kinetic energy u square, and due to the final velocity its kinetic energy is v square. Okay, and a body of mass m moving with initial velocity u, due to the external force along the direction the body get displacement s, and change in velocity is v, and change in velocity give the acceleration is a, student. So there are two methods, student. So first method, work done, which is equal to F into S, that is theta is equal to 0, cos 0 is equal to 1, student. Force and displacement both are along the same direction, so that work done is positive, so that I can write W, which is equal to F S into cos 0. Cos 0 is 1, so W is equal to F into S, student. But I can write there Newton's second law, F is equal to ma, so that W is equal to ma into S. Okay, in this equation acceleration I am going to replace, student. For this acceleration, from equation v square minus u square is equal to as formula using, student. In this, v square minus u square divided by 2s, which is equal to a, is the acceleration. So initial velocity, final velocity, displacement, acceleration, so that the value of acceleration is replaced in the work done equation, student. So that we will get here W, which is equal to, here writing, student, W is equal to m into a value is v square minus u square divided by 2s, and s is there, s is get cancelled, so that I can write here work done, which is equal to half m v square minus u square, student. Rearranging this equation, the work done is equal to half m v square minus half m u square. Okay, so that work done, which is equal to, due to the final velocity, final kinetic energy, so that is kinetic energy final, minus due to the initial velocity kinetic energy is initial kinetic energy Ki, student. So that W, which is equal to final kinetic energy minus initial kinetic energy. Okay, student, and that W, which is equal to final kinetic energy minus initial kinetic energy, written as work done, which is equal to change in kinetic energy delta Ke, student. And also we can write equation W work done, work is equal to delta Ke is change in kinetic energy. This is clear information about the work energy theorem, first method, student. And second method, using here the basic formula is v square minus u square is equal to s, and both sides multiplied by half m, student. So that half m into v square minus u square, which is equal to half m into 2as, student. In this derivation, here 2 get cancelled, and ma, which is give the force F, replacing in the above equation, student. So that the continuation step is half m v square minus half m u square, which is equal to F into S. But F into S that give the work done student. It is replacing in the above equation, so that W which is equal to half mv square minus half mu square. So finally I am getting here work done W which is equal to final kinetic energy minus initial kinetic energy, that give the change in kinetic energy delta Ke. So that here work done which is equal to change in kinetic energy. See student, please do like and subscribe our channel Nature of Physics.